Hello, everyone, and welcome to our webinar, Build Real-Time Document and Image Analytics with GPT-4 Vision. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You can submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a SingleStore webinar, a heads up that we present regular webinars demoing data and AI use cases and new technologies and tools. So on Wednesday of this week, we will be presenting another webinar. If you click to the next slide, you'll see the title of it is How to Create Embeddings on Real-Time Data with OpenAI and SingleStore Job Service. Come watch a demo our team is going to be doing on scheduling ongoing vector embeddings on real-time data from online sources like Reddit or Twitter or anything else. If that sounds interesting to you, you can RSVP at that tiny URL that's on your screen. I'll put that in the chat in a minute. You can also take a photo or a screenshot of that QR code. That'll take you to the same place. So RSVP, and I hope to see you there on Wednesday, 2 days from now. Back to today's topic, we have some fantastic experts that are part of this Zoom, ready to answer your questions. So keep them coming throughout the session. We'll also have a dedicated live Q&A at the end of this session. So stay tuned for that. We'll try to get to as many questions as we can. We'd also love for you to try out the technology that we're showing off today. In fact, anyone who tries it today will be entered into a chance to win new AirPods Pros, the latest and greatest from Apple. All you need to do is click the link, tiny URL, that's the GPT-4 Vision raffle. I'll put that in the chat as well in a minute. You can do the QR code as well, and it's very easy. All you need to do is log into SingleStore. We have a free trial. We also, if you're paying attention during last week's new feature releases, we also have a fully free tier, not a trial, a fully free tier. So if you want to check that out, or if you're an existing account, or if you're an existing customer or an ongoing trial, all is eligible. All you have to do is log into that link, and we will check the folks who log in. We will announce the winner of the AirPods by the end of today's session. So I'll put that link in the chat in a minute. Let me introduce our speaker for today, Ayush Pai. Ayush is a computer science student at Georgia Tech. I originally found him online after a viral AI basketball referee demo that he created. Since then, he has created several very, very cool AI demos. We've been partnering on a lot of projects that demonstrate the power of SingleStore DB for AI applications. Ayush, good to see you again. The floor is now yours. Or I think Akmal, actually, you're going to start us off today, aren't you? I'll hand it over to you.
Yeah, great. Well, thanks very much, Matt. And thank you to Ayush as well for his awesome contributions. I mean, I think if you look at the work that he contributes, I mean, go to his GitHub repos, you get some very cool stuff, all the latest sort of tech being used for really, innovative sort of demos. Okay, so there we go. And for those of you that joined last Friday, as you can see, I'm not Matt Brown. Matt is back, okay? So he's using his own account. And so I get to present a couple of slides. And I promised I'll be fast, okay? So we just 2 slides just to say a little bit about SingleStore DB, and then we give Ayush the floor, and he'll walk through and present his slides and his demos. Okay, so first slide, SingleStore DB, what is it? It says the world's only database that empowers users to transact, analyze, and contextualize data in real time. So we are a real-time database engine. We are based on relational technology. Go back in time a few years, used to be called, the product and the company was MemSQL, okay? You might have heard of us. And subsequently, in addition to the in-memory stuff, we added the analytics, columnar storage, to be able to do, these operations, sum, min, max, average, count at scale analytics. So it does both the OLTP and the OLAP. I mean, that's the key thing. And we've got lots of other things as well, such as feature, streaming data ingestion, point-in-time recovery, distributed, shared nothing, MySQL compatible architecture. So the 2 things to remember here is that it is MySQL wire compatible. So if you come from the MySQL world, in particular, for example, the tools, technologies that you've used, you can plug those in. Your skill set would, translate, move across very easily as well. And it is also MongoDB compatible. So just last week, we announced the GA of SingleStore Kai, which has been in preview mode for a while. And that gives you the MongoDB sort of support, if you like, or we are compatible. Let's put it that way, I think, rather than the other way. Architecturally, then, is the 30,000-foot view that we often like to show. It's a great way to kind of see where the product kind of sits. And so here you can see at the center here, we have this universal storage, okay, handles those two processing types that I mentioned. On the left-hand side, we've got a variety of ways that we can get data in. So touched on streaming already. So Kafka, for example, which is something that I use in a lot of my webinars. I come from Databricks some time ago, so I'm familiar with Spark and sort of transformations and machine learning. And then we've got other technologies out there as well, such as Hadoop, HDFS, for example, or S3. And these are places then, which I think what this animation is trying to show you, where you can ingest the data at scale, okay, and in parallel. We work on all the three major cloud platforms in the Western world. So AWS, Google Cloud, Microsoft Azure. And today we are going to be using AWS. Okay, so Ayush will be focusing on that and showing you that. We can run on-prem as well. There's a Docker container too. But seriously, the link that Matt provided, and I think he's posted in the chat already, if you go there and you sign up, it's a cloud-based environment. Matt mentioned this free tier. I've been using it just for the past couple of days and actually using it earlier today as well for some work. I'm preparing some demos and code for the webinar that I'm doing next week on approximate nearest neighbor and vectors and how you can utilize the latest kind of developments from SingleStore in that space. Multi-model, okay, as opposed to multimodal, which is what we covered on Friday. So SingleStore at its heart is a relational database management system, but it does all these other cool things as well, okay? So it can do geospatial, for example. We've covered those in the past. Time series. We can do also, full text search, the Lucene full text search engine built in. JSON support, that's been there for some time. That's got even better with the SingleStore Kai and compatibility with MongoDB, and of course vectors. Okay, very hot topic today. Keep in mind that vector support has been in SingleStore since 2017. Right? It's not something we just added because it's popular these days. It's actually been around for some time. It's battle tested, mature, but lots of new stuff announced last week, Wednesday. And I'll be covering some of those in the webinar next week. Okay, so please stay tuned for that. And then finally, in terms of the kind of things that you want to do, you build your real-time decisions, IoT, dynamic experiences, dashboards. So if you're familiar with things like Tableau, for example, or Metabase, which is the tool I tend to use often, simply because there's a free version available and very simple to use. It's just a jar file. Ad hoc queries, again, there's a built-in SQL editor. And so having this cloud-based environment really gives you the opportunity to utilize a lot of these things without having to install anything locally, which makes your lives as developers a lot easier. And with that, I'll stop sharing at this point and hand this over to Ayush. So there we go, Ayush. So over to you, sir.
Awesome. Okay, I think you should be able to see my screen now. So yeah, thank you for that great introduction, Matt and Akmal. Welcome everyone. My name is Ayush Pai, and I'm a current computer science student at Georgia Tech. And I'm really thrilled to welcome you to today's webinar, where we'll really be delving into the world of real-time document image analysis, but with a twist. We're going to be using GPT-4 Vision. And I've done a presentation with SingleStore before with GPT-4 Vision when it just came out, right? And there was some really cool applications that we saw. But specifically document analysis is kind of what we're going to be focusing on today. And specifically our demo is going to be in the insurance industry. So before we explore the technical marvels of our topic, let's really start with the basics. And what is artificial intelligence? And AI is really a transformative force in the realm of computing. It's really driving machines to emulate intelligent human behavior. And unlike traditional software, AI systems have the remarkable ability to learn, reason, apply knowledge, and a lot of the times they're actually outperforming humans in various specialized tasks. And AI is not just like a monolithic technology. It's actually a whole branch of computer science now that kind of like started in the 1900s, and actually with Alan Turing, the father of computer science, also known as the father of AI, with this Turing test. And from there, we saw all the developments in AI up to today. And there's many different techniques within AI, including machine learning, natural language processing, computer vision, robotics. Each of these domains really contributes to AI's ability to process and analyze the data that's processed in a really a profound and nuanced way. And as AI really continues to advance, reshaping industries, reshaping societies, really offering new novel solutions, also brings ethical and practical challenges. And today's session, we will not only discuss these aspects, we'll also demonstrate them through a practical application in the insurance sector, as mentioned before. And by the end of this webinar, you'll gain insights into how GPT-4 vision can be harnessed for advanced document analysis, image analysis, and learn techniques for real-time data processing when it comes to SingleStore and integrating SingleStore with AWS into this technology and actually using this AI analytics directly into your business workflows. So moving into the core of our discussion, we kind of narrow our focus of AI into computer vision, right? Computer vision is really a pivotal field in AI, and it really seeks to endow machines with the capabilities for high-level understanding of digital images, videos, and really mirroring the complexity of human vision. This discipline really encompasses a spectrum of tasks that include image and video recognition, object detection, image generation, image segmentation, and at its heart are really sophisticated algorithms, deep learning models that really enable the extraction and interpretation of meaningful information from visual inputs. In practice, computer vision is really employed across a diverse range of applications. It's the technology behind facial recognition systems on your phone, for example, or enhancing security. And it's really vital in the operation of autonomous vehicles that really navigate our streets today. And in the medical field, it's really critical in the role of analyzing imagery for diagnostics. And within the insurance industry, it's really becoming a role to assess and process claims in a greater accuracy and efficiency. And our webinar will really delve into this in these technical facets of the insurance industry and really examining how these algorithms process and analyze visual data, and also documents, and discussing how this integration of computer vision into real-time analytics can apply, or it can really demonstrate its application and really evaluating insurance claims, where it can discern damage from types of car accidents, and really assist in estimating payouts. So as we delve deeper into the realm of AI, let's take a moment to really appreciate kind of the significant milestones that have led us to today's technological wonders. So the journey of AI really began with the rapid revolution of groundbreaking innovations over the last few decades. It was where the conceptual starting point was with the Turing test and then the perceptron in the 1960s. But really in the 1990s and early 2000s, really laid the groundwork for modern AI, laid through the emergence of machine learning algorithms and neural networks. So this era was kind of characterized by intense research, first through practical implementations of AI, and really set the stage for more advanced developments in the next century. The first decade of the 2000s really saw a surge in data mining and the development of AI in real-world applications. This period focusing on enhancing robotics, speech recognition, and really integrating AI into consumer products from very low level. And the 2010s were really transformative in the deep learning world. So landmark advancements such as the development of ImageNet, which really propelled significant improvements in image recognition and natural language processing. And this period really really democratized AI's accessibility, really leading to pervasive integrations across industries. So Currently in the 2020s, we're really witnessing this next era, which is the era of large language models and multimodal models, starting with BERT, which is kind of the predecessor to the GPT series that we see today. So these models have revolutionized AI's capabilities, allowing them to have a deeper understanding and really a deeper understanding of like the generation of human language and like an unprecedented scale with a lot more context. They really exemplify the culmination of the years of AI progress and kind of represent the frontier of what's possible with this current technology. And as the AI landscape really continues to evolve, and with each of its advancements, we're not only redefining the limits of machine intelligence, but also reshaping the future of how we interact and benefit from this technology. So really the future of AI is multimodal, right? The progression of AI really significantly increases its characteristics of multimodal capabilities. This evolution really reflects a shift from singular data type processing models that can interpret and to models that can really interpret and analyze a diverse set of inputs such as text, images, audio. From 2019 to 2023, the development of large language models such as BERT and the GPT series really showcased the potential to revolutionize numerous sectors by enabling more nuanced and complex understanding of data, specifically text data. But with GPT-4 Vision launched at the latter end of 2023, we really saw the representation of large language models that have multimodal aspects. And the architecture is really designed to assimilate and process visual and textual information concurrently. And this is really significantly enhancing the model's interpretive and inferential analysis because it'll have access to multiple types of input. Similarly, at the end of 2024 or end of 2023, Google released its Gemini series, and Gemini Ultra, which they position as their most advanced multimodal model, was really designed from the ground up to be multimodal. So they wanted to really start off with just one model that could interpret many types of data and really be a comprehensive model capable of synchronously handling image, text, audio data at the same time. And that's slated to release in Q1 of 2024. The AI landscape is also witnessing a surge in the development of open source models that can really parallel or even challenge these capabilities of GPT-4 Vision. If you've checked out Hugging Face, you can kind of see like the leaderboard of these rankings, kind of how they compare in terms of GPT, GPT-4, GPT Vision. And these models really contribute to a competitive and diverse AI field, really accelerating the advancements. And obviously, open source is always better than closed source. So that's really making this field a lot better as well. And some of these developments kind of underscore a pivotal trend towards more sophisticated, multimodal AI, and really enhancing the ability of machines to interpret complex information. That's taking us closer to AGI, where it can really be indistinguishable from a human. So a GPT-4 Vision, according to OpenAI, really excels in deciphering and responding to general inquiries about content within images, reflecting on its sophistication and image understanding. So the model's strengths are kind of with these several core functionalities. So first, we have object detection, which really underscores the ability to understand what's in an image and understand what the objects are. And this, for example, like you could ask GPT, what is in this image, and it'll be able to detect using some sort of object detection, like based on what's in the image, it can give you a result from that. This also includes, so one of the other strengths, obviously, is optical character recognition, OCR. And OCR has been here for a while. There's been a multitude of OCR algorithms in the past, which OCR, what it does is basically reads printed text, and it can take that from an image and turn it into actual text. But GPT's OCR system is really, really well defined, and also extends to accurately interpreting, in a lot of cases, handwriting. Furthermore, GPT-4 Vision has shown a really great ability to identify content within obscure images, showcasing advanced pattern recognition that it can be crucial in fields where clarity and precision are paramount. And it also demonstrates a prowess in generating code from visual mockups, a feature that really streamlines the development of software applications. Additionally, the model adeptly interprets complex diagrams and visually dense information, really simplifying the extraction of valuable insights from an image, which previously would have taken a lot more time with some antiquated techniques. And lastly, its ability to identify landmarks from visual data highlights um, really shows its potential in geolocation, navigation, self-driving applications, right? These strengths collectively underscore GPT-4's vision and kind of show the direction that we are going with this multimodal AI. So one of the core competency obviously is object detection, and that's a critical function in understanding and interacting with the visual world. So the model is really trained to understand foundational questions such as what is in this image with good precision and contextual awareness. For example, in this image, we have a typical office setup, and GPT Vision can accurately enumerate the number of items in the desk. I think there's a few errors in this specific example, but it can do a pretty decent job of identifying what's on the desk from the left to the right, distinguishing between the framed artwork and the desk and the lamp and the monitor and these different objects in this pretty packed image of a bunch of different objects on this desk. And this ability to process such queries really reflects on GPT-4's sophisticated pattern recognition algorithms, which can discern objects and their spatial arrangement. And this capability is really invaluable across various sectors, enabling automation of tasks that really require visual identification and cataloging, where you need to, for example, you need to have some sort of like automated warehouse cataloging or something where you're actually tracking objects can be very useful, enhancing productivity and really paving the way for new applications that were kind of previously unattainable. And by integrating these functionalities, GPT-4 Vision not only kind of augments the efficiency of existing systems, but also kind of extends the boundaries of how machines perceive and understand visual elements of a world. So GPT Vision also extends to interpreting complex diagrams, which is a task that really demands high levels of cognitive and analytic processing. So this model can dissect, integrate electronic schematics, really identifying and explaining components such as microcontrollers, oscillators, capacitors, LED circuits, and many more. And it's doing this, and this capability is really particularly beneficial for educational purposes, technical troubleshooting, engineering design, in a lot of cases where understanding such diagrams is essential. So GPT Vision really streamlines these processes by providing clear, concise explanations, enhancing learning and innovation in technical fields. So one a really cool example that I really like personally here is GPT Vision's utility also showcased in everyday scenarios. That's probably where it should be the most useful, where AI should help the most amount of people in everyday scenarios where, for example, this is a really complex parking sign, and you want to avoid tickets, right? And you're asking the simple question, it's Wednesday at 4 p.m. Can I park in this spot right now? And so GPT Vision can process the sign's information. And for example, you can have OCR algorithms in the past that could do this. That could interpret what's in the image, extract the text from the image, and give you the text, right? But that's not what GPT-4 does. GPT-4 is able to perform this real-time OCR and on these real-world images, understand the context, and then provide an actionable information. So understanding the context and getting this OCR information makes it 10 times more powerful than any OCR that just gives you the result would give you. So such capabilities can really be integrated into mobile apps for real-time assistance, significantly simplifying daily tasks for users that were previously very complex. So GPT Vision also extends its capabilities to landmark identification, where it can accurately recognize and describe prominent landmarks and images. So the AI can really detail historical and cultural images, context, and it can, as seen in this description, and this is directly from the GPT-4 Vision paper released by OpenAI as an example. So the AI can really detail historical and cultural context, as seen on descriptions of New York City's Times Square and San Francisco's Lombard Street. So this function really aids in enhancing user experiences, really providing rich and descriptive narratives that offer more than just a name, but actually a story and a significance behind each landmarks. GPT's innate core competency is on not only actually analyzing these images, not only just doing object detection, but actually taking that context and putting it into more descriptive narratives that can really give you a lot more information. And yeah, this is another key feature that's really useful from GPT-4 Vision. So as I was saying, this OCR technology is great. In a lot of cases, GPT-4 can also recognize handwriting. So GPT-4 is a significant step forward in this OCR technology. There has been OCR technology in the past that can do a decent job at handwriting, but there's been a lot of tests with GPT-4 and it's done a really great job. And it's not just about recognizing the characters, obviously. What I was saying, it's about comprehending the context and what they're used by, and then interpreting the handwriting, mathematical calculations and solutions on homework assignments, for example, in this scenario. So GPT Vision can really accurately transcribe handwritten notes, verify the steps and answers, and involved in actually problem solving. In this case, it actually goes through the whole problem solving process that the student in this picture actually went through. And GPT-4 Vision can accurately transcribe the handwritten notes and verify the steps and answers involved at every problem solving step. For example, it can confirm the correct application of mathematical strategies. And as seen as in this homework, it's doing the hundreds, tens, ones, for example. So this application of GPT-4 Vision kind of has a profound implications for educational settings where you for example, like you're doing a very complex math equation, you write it all down on a piece of paper, but there's no way to check your answer. Previously, there was Photomath. I'm not sure if you guys have ever used that, but Photomath was a really cool tool, but it was only based on previous results that I found or previous or simple like equations that it can already transcribe really easily. And GPT-4's vision is really great with OCR here, but also it's additional context to provide a lot more detailed information from its trillions of parameters that it's trained on. Really facilitates a more efficient interactive learning experience. So yeah, handwriting is a really great way to do document. So this kind of like flows into document analysis, right? So document analysis that we're going to be doing with our insurance demo or later on. Documents are not always going to be written in text. There's going to be a lot of documents that you might have like handwritten or like partially like this paper kind of like, for example, it's kind of partially typed, partially handwritten for parts that are filled out, for example, like an insurance form or something like that where you have to fill it out. And a lot of times it's very difficult to kind of transcribe that or kind of take that into like an automated system where you can interpret what's going on. But GPT-4 Vision, with their contextual ability to understand what's going on top of the OCR, can really help, and we'll see that later on in this demo. So before we go on, I do want to mention, obviously, GPT-4 has weaknesses. And it's not to say that these will be here forever, but just at the current moment, it kind of represents a substantial advancement. But it's important to acknowledge the limitations. So these are actually noted by OpenAI themselves. So the model is not designed for interpreting medical images, such as CT scans, cannot provide medical advice. Its performance with non-English languages, particularly non-Latin languages and alphabets, is limited due to the less extensive trading data based on those languages. So the model may also struggle with very small text and complex visual elements, such as interpreting graphs with varying line structures or detailed spatial reasoning tasks like identifying chest positions. But being aware of these limitations is really crucial for developing applications with GPT-4 Vision and setting realistic expectations for deployment in various applications. So let's kind of talk about what the current document analysis techniques are, current and previous techniques, before we get into this new technology that we'll discuss today. So the evolution of document analysis has kind of transitioned from labor-intensive manual review that you saw before computers, and just to kind of a more advanced automated process. So initially, document analysis was kind of really predominantly a manual task, right? It was really requiring extensive human effort, for reading, interpreting, and really categorizing information, sorting into, like all these file cabinets. And it was a really extensive process that that not only was time consuming, but really prone to human error, inconsistencies, and really subjective interpretations. So the introduction of basic software tools, such as Word, Excel, PowerPoint, etc., all these tools by Microsoft that came out in the early 2000s, really kind of marked a significant improvement, provided a keyword search capabilities, elementary pattern recognition. How these tools kind of lack the ability to grasp and really get the deeper contextual meanings within the documents, and kind of limited the application to more straightforward tasks. And yeah, it might have solved the problem of, you don't have to use file cabinets anymore with computers. You don't have to use like that type of stuff, but you still have to have a human read and, analyze every document, which can be still a very time consuming, error prone process in a lot of cases. So early automation efforts kind of saw the implementation of optical character recognition, as we were talking about earlier. So some basic OCR technologies in early 2010s, all throughout the 2010s, we had really basic OCR technology, and it did get very good towards the end. But so this is really facilitating the digitalization of text, right? So we have these papers, and we can really these physical papers, you can really digitalize them in a great way. Despite this progress, these techniques have kind of limited the capacity of um, understanding complex document structures, or to infer the meanings and nuances that lie within the text. But today's document analysis requires a blend of speed, accuracy, contextual understanding. And these are all areas where GPT visions and capabilities can really make a substantial impact. So the transition from manual automated analysis has set the stage of new AI tools that can process information with a high level of understanding, with approaches in human with really parallel levels of human cognition, even higher, for example, and really marking a new era in data management and analysis. Oh, and while we're here, we should also mention so we did talk about kind of like the downsides of GPT-4 vision, kind of the weaknesses. And some of the downsides of GPT-4 extending here is if you're doing document analysis, you're fully relying on something like GPT, some large language model, some multimodal model to do this. Obviously, over time, it's going to get better, but it's always important to have a human always do like a second report, or some second analysis, where there are a lot of instances where currently large language models do hallucinations, which is they actually output something that seems to be very confidently true, but in a lot of cases that's very false. And those are called hallucinations. And there are a lot of techniques and research efforts right now in this space that are kind of trying to limit hallucinations as much as possible. But right now, especially, it's really important if you're going towards an automated effort with large language models, GPT-4 vision. It's always important to have a second human reviewer at this time. So now, yeah, we can get more into the GPT-4 vision powered document analysis. So this has really, GPT-4 has really advanced the field of document analysis by enhancing OCR technology, obviously, with the combination of the ability to understand context and text and images. This combination really leads to a more nuanced interpretation of documents, which really transcends into mere text recognition, really transcends your text recognition to really understanding underlying meanings of documents. So its automated content summarization is one of the key capabilities I could do. So by summarizing categorized content, by extracting key features from documents, obviously documents, a lot of times, you don't need all the information from them, but by summarizing and categorizing key information from the documents, GPT-4 Vision really reduces the need for laborious manual efforts and really saves substantial time. Moreover, GPT-4 Vision really excels in advanced data extraction and analysis, so it can really accurately identify and interpret complex data structures such as tables, graphs, and which are really more challenging for traditional OCR software. And this really enables a deeper and more accurate analysis of documents, really automating tasks that are previously required human expert intervention. So this really together features kind of shows how these are kind of like on the screen right now are just kind of like some features that kind of exemplify how GPT-4 Vision is reshaping document analysis and providing tools that are not only efficient but insightful, really empowering businesses and individuals to handle information in more intelligent ways. So now we can get on to our demo and how we're going to make this today, kind of like more technical side of this. So we're going to be doing a document and image analysis for insurance claims. So in this focus, yeah, we're going to talk about how GPT-4 vision can be leveraged for insurance claim analysis, and just the whole car accident process of, you have your picture evidence, you have your insurance claim, you have maybe a list of damaged parts, and the integration of advanced OCR, contextual understanding, allows us to make a comprehensive analysis of both documents and images in a critical need for, insurance claims. So GPT-4 Vision automates damage assessment by really evaluating images of car accidents or property damage by and these are some examples of how it can work here. So it could be cross-referencing, these document claims. It can do some dual analysis to really ensure quick and accurate assessments, reducing the time taken to do this process. The AI's ability to compare claim details against historical data, using some type of fine-tuned model or, analyzing images and enabling robust fraud detection can really identify inconsistencies and anomalies and can suggest fraudulent activity, and can, safe by kind of like false claims or insurance fraud, etc. And so these are some just use cases of GPT-4 Vision and a lot of here. And so finally, we can also consider the case of, the overall impact of the claims process by streamlining the assimilation of visual and contextual information. GPT-4 Vision can really facilitate faster claims processing. And this improved efficiency kind of leads to an increased customer satisfaction, gives quicker resolution to claims, and can really provide some innovative solutions in the insurance space. And these are just some examples of how it could do that through like automated damage assessment, fraud detection, and streamlined claims processing. So let's get started with the GPT-4 Vision API. So the first thing you do, if you haven't used it before, is to go to the OpenAI website. And this is a gateway to access the API, the resources provided by OpenAI. You'll find comprehensive documentation, user guides, etc. So you'll need to have an OpenAI account if you don't already. This account is really essential for the API. So once your account is set up, you'll be able to create an API key, and this will allow you to access all the models through your specific account. And finally, you'll integrate this API key directly into your Python environment or Node.js environment, whatever you're coding in. And this integration will be a crucial step that connects your development environment to OpenAI services. So here's the provided code. It's in Python to kind of show you the setup process to make an initial request to GPT-4 Vision for image analysis. So initially the script imports necessary libraries. So it includes OpenAI for API interaction, OS for interpreting like OS operating system interfaces, base64 for encoding binary data, which is required for images to be inputted into GPT-4 model, and so the user's OpenAI key is securely retrieved from a environment variable. So environment variable is really good in this case. It ensures that you don't have your API key hard coded into the script. So this encode image function that we see right here is the essential goal of this is kind of convert the image file into base64 encoded string, which is the required format for transmitting binary content through the GPT-4 API. And this simple code is on the GPT-4 on the GPT documentation. And it kind of explains why you need to encode it. But finally, the script executes a call to the completions.create method of the OpenAI client. This is just the gateway to actually accessing the GPT models. So the first parameter here is model. You can change this to whichever model you're using. In our specific case, we're using GPT-4 Vision. And then we have our messages. So the messages include the roles. So the role is the first parameter here. So the role is the user. And the content of the user's message is what is in this image. And we can say And then we can also include another piece of content, which is the image URL. And the image URL, you could actually use like like an image from the internet, or you could put in your own image, which will have to be base64 image encoded. And at the bottom, just how many max tokens it wants. And then you can print it by doing response.choices 0. That'll print you the whole output and of the model. And that's how you that's just the basic process of starting with the GPT-4 Vision API. So let's just go over like what we're actually building here, right? Let's define the inputs and outputs. So from a high level, we're developing an AI-powered car insurance agent, right? It's designed to streamline the claims process by automating the damage assessment and payout estimation. So the AI agent will be fed with various inputs. So in this demo, we're going to be feeding in a photo of the car accident to visually assess the damage, a CSV file with a car repair estimate, detailing kind of like the required repairs and costs, and a PDF file of the car insurance claim that includes the policyholder's details and the specifics of the claim. So from there, these inputs, the AI agent will generate a comprehensive output using the GPT-4 model. So it will analyze the provided photograph and documents and understand the extent of the car damage, validate the repair estimates against the visual damage, and cross-reference the insurance claim details in that PDF. So the expected output is a detailed analysis that includes an informed estimate of the payout amount based on the assessed damage and the terms of the insurance policy, all compiled into really efficient manner without manual intervention. So this solution aims to enhance the overall accuracy and efficiency in doing these insurance claims. So the process of utilizing GPT-4 Vision for insurance claims, let's look at the inputs first here, right? So the three inputs that we're going to be giving it is a photo of the car accident, a CSV file of the car repair estimate, and a PDF file of the car insurance claim. So to streamline the analysis and harness the full capabilities of GPT-4 Vision, all three inputs are treated as images. And the rationale behind this approach is kind of to demonstrate in this specific demo the robust document analysis and OCR capabilities of GPT-4's Vision. Obviously, we can put it in as just textual input or where you can actually convert the CSV into actual text and put that directly into the system message or the input itself. But we're kind of demonstrating the document analysis abilities and the OCR of GPT-4 Vision here. And so this allows GPT-4 Vision to perform kind of to show how GPT-4 Vision would do a document analysis. For example, if this, for example, was a physical piece of paper, the insurance claim was a physical piece of paper, or something where it's like there's not really a streamlined way of converting it to text, or there's like a lot of handwritten stuff on the document, and GPT-4 Vision can unify this analysis across different formats, and it kind of underscores the AI's ability to handle diverse data types in a single workflow. So this slide introduces the function we created here. So this is for image analysis. So there's two stages, image analysis and document analysis. So image analysis in this case is specifically for the picture that the user will submit for the car accident. So the prompt provided for the analysis here is visually describe this car accident, explain the damage on the car, and return a detailed accident report. Which really instructs GPT Vision to perform a comprehensive analysis of the visual input and present the image, a visual input in the image, and kind of like understand what happened in the car accident. And the function initiates an API call by calling the chat.completions.create method, and passes in the model identifier, which in this case we're using GPT-4 Vision. This is kind of similar to what we discussed earlier. And upon receiving the response from the API, the function extracts the text content of the message, and it also uses the image from the base64 that we inputted here, and it's going to output an analysis that GPT-4, and it's pretty, a lot of the times I've tested this with a different car accident, different scenarios, and it does a pretty decent job of explaining the damage, explains what parts of the car is damaged, explains like, you know, how many cars are involved, like what the color of the car is. It gives a good visual analysis of, you know, like what kind of happened at kind of like a high level in the accident. So kind of exemplifies how GPT-4 vision can be applied in, you know, practical scenarios such as car insurance claiming, car insurance claims and processing, where, you know, quick and detailed analysis of visual data is crucial. And the function demonstrates the potential of GPT-4 vision to, you know, transform and automate aspects of insurance industry. This slide kind of shows the document analysis side of things. So what we're doing here, our goal is to really, you know, do document analysis to convert the image of full text, maybe some, you know, handwritten text as well, into an actual text that can be used by the computer, that can be like turned into actual like string text that can be used for GPT-4's analysis. So we're going to use GPT-4 Vision's OCR capabilities, and what the system prompt here is. And by the way, let me explain a little bit about these roles for OpenAI. OpenAI has 3 roles. So the role here is system. System is kind of like the overlying role, which kind of you set what the agent should be doing. You're kind of saying what their role should be, what they should be aiming to do. And kind of like the user role is more of what the specific prompt of the specific scenario is. And the assistant role is the last one. I think we'll see it on the next slide, but that's more to provide additional context, additional information to assist the, you know, the model in, you know, completing its analysis. So in this case, yeah, so the system prompt is you are a scribe, convert this image text to a format, text output, nothing else. And this, the only use case for this is to literally just take a document image. It could have a bunch of, you know, handwritten text as well. And it performs OCR using the GPT-4 vision model, and then returns text that could be used directly for further analysis. And so here is the accident analysis method and completion. And so what it's going to be doing is we had the accident report. So basically these two are to do image analysis and document analysis. And then we take in that accident report, it reports from right here, from using GPT-4. And then it takes the car repair details and the insurance claim from the document analysis, takes all 3 of those things and puts them into the assistant role that we see right here. And the prompt is, you are a car insurance agent. Your job is to analyze the following documents, including insurance claim document, a detailed description of the damage, and a CSV of the car parts and prices. Your goal is to use this information to infer the type of damage and make a payout estimate based on the CSV. So it's going to be using all this information from here to create a very detailed, a payout analysis and kind of like assessing what happened in the car accident. So another thing that could be very useful is actually vectorizing these documents. For example, you know, the PDF, once you have that analysis, actually vectorizing what comes out of it. So, a vector, let me explain kind of like what this technique is. So vectorizing documents is a technique where, you know, text data is converted into numerical vector format using embeddings. So this process transforms the text into a form that machine learning algorithms can understand, and something that really can be used to quickly search through by creating a database of vectors called a vector database. It allows for efficient querying and comparison and retrieval of documents. So this vector representation is crucial in enhancing the performance of our AI agent, makes it more responsive, and it can really enable the AI to quickly identify patterns. And to facilitate this, a suitable storage solution is really required to house the vectorized data. And the storage must be capable of handling high-speed data writes, reads, serve the vectorized data effectively to the AI agent when needed. And the sufficiency of this storage directly impacts the the agent's ability to rapidly access and analyze the vectorized information, which can be really useful for conversation in the future, additional context within within this conversation, and through other applications where you can do fine tuning with these embeddings, or you can do something called retrieval augmented generation, which is RAG, which allows which allows your AI agent, your actual model here, to retrieve information really quickly from this vector database by doing some sort of like vector comparison or vector search, such as nearest neighbors or cosine similarity, something where it can actually really quickly retrieve this information, and that's why this is very useful. And that's why SingleStore is a database which is really engineered for real-time analytics. It's characterized by its ability to handle transactions and analytics simultaneously on a really single platform. So it really particularly is effective for scenarios that require fast querying of retrieval that large language models do in a lot of cases for volumes of data such as vectorized text and AI applications. And SingleStore's architecture is designed to really deliver on high performance for both in memory and on disk data. So it makes it really ideal for vector database management where speed and efficiency are critical. And the given code snippet here kind of exemplifies the process of storing documents in a vectorized format using LangChain and OpenAI's embeddings. So LangChain right here is going to be used to kind of load the text into a text loader. We're going to be splitting it into these documents with a chunk size of 2000. And the embeddings are by OpenAI to create these vectorized embeddings that are going to be stored directly into our SingleStore DB. And we're going to be using a table called insurance claim. So yeah, we can easily store and retrieve these vector documents with SingleStore, which can be really useful for fine tuning or doing RAG in future applications, which can be really useful. So let's do a little demo and code walkthrough. So I think we have like 10 minutes here. So let me share my screen. Okay. Okay, so yeah, you should be able to see, Matt, can you double check, double confirm if you can see this right now?
Yeah, I can see it. If you're able to full screen it or zoom
Got it.
in, that'd be even better.
Yep. Okay,
Great.
so this is kind of the code that we had, that we had like demonstrated throughout the presentation. So we have the encode image function that kind of like takes through your image path and turns it into base64, which is really useful for actually putting it directly into the GPT-4 model. We initialize our OpenAI client. And so this is our method for analyzing images, right? So we have a prompt, which is going to be specifically asking for, and I can show you what the prompt is in that scenario. So we're going to be saying visually describe this car accident, explain the damage on this car, and return a detailed accident report. And so that's the first thing we do. We want to generate that accident report, and we're going to just print it out and see what it comes up with. But the next step is actually, like getting the car repair details. And we have the CSV file, just a quick example of, this is not a real example. This is kind of like some data that I created just randomly. But for this specific car accident right here, we have this car that just kind of hit a tree. And here are the car estimate repairs. And so you feed that in, you also feed in like an insurance claim. This is just like random information again, but it kind of just for demonstration purposes. So that's the PDF, but what we're going to be feeding in is actually the images. So this is just an image. For example, if you don't have a digital copy of this insurance claim, you just take a picture of it. And for example, also for the repair, it's actually just a screenshot of this specific thing. So that's just to clarify it. It's just images. Only thing without inputting is images because we're kind of demonstrating how this GPT-4 vision is working. So yeah, we have the analyzed document for both the car estimate and the insurance claim. And the final accident analysis is done by, really combining this accident report, this car repair details, and this insurance claim in this one function here where we do analyze accident. We have our big prompt here to kind of like get that, and we have the assistant kind of providing that information. And our final step here, obviously, is very important for future use cases when you're trying to fine tune this model or do a RAG on your application. So what we're doing is just, doing the text loader, we're splitting the documents, creating the embeddings, and putting them directly in the SingleStore DB. Let me actually demonstrate now this function, this in action. So the first thing it's going to be doing is actually, creating this accident report based on this car accident image right here. So it's going to be running that through it's putting this image through the GPT Vision, GPT-4 Vision API, and should be running now. Okay, so here's what it came up with. So from the image provided, we observed a damaged vehicle in the image. So blue hatchback sustained significant damage in its front end. The HUD of the driver is completely crumpled, bent out of shape, driver's side, etc. The headlight assembly, the front windshield, driver's side wheel, all seems to be decently correct, decent conclusion. So the car has come to a rest, whether against a tree on the side of the road and sustaining front end damage, etc. So it seems to be a decent accident report. Then the next step was actually, analyzing this document with the car estimate report. So it's actually not doing the CSV, but it's actually taking an image of the document. So where is that? Right here. Oh, right here. So it's taking this image, it's actually doing OCR, and it does a pretty good job. It gets everything correctly into this right here. And then the insurance claim document, which is it's actually like taking the insurance claim and from right here, and it's doing OCR on this and extracting all the information from there. And from that, it creates the final final summary of the findings. So it does a policy owner, vehicle model, incident details, kind of shows all this information right here. And also, you can create a detailed analysis, a PDF output of all this information, right? So based on all this information, it's able to create, like damage to the steering, etc. Estimated cost of 1,500. So based on the CSV breakdown, unforeseen repairs. It can, for example, there's a lot of stuff here, and it kind of just shows how this can be used. It's just an example here, but yeah, we can get into questions now. Matt, I think we only have 4 more minutes. So. Yep.
Yeah, awesome. Let's do it. And we'll answer everyone's questions via email if we don't get to them today. I'm gonna group some. There's been a popular question about sensitive information, alternative APIs. Is there any way that you can guarantee what you're sending to OpenAI is not getting trained on or could be leaked somewhere? And I know that I wonder if this might be relevant to we've done other webinars on fully local solutions, keeping everything nothing goes to the cloud. So Ayush, you're welcome to take an answer at it, and Akmal, you're welcome to chime in too.
Yeah, so definitely GPT-4 Vision, or just the GPT models in general, it uses kind of your data to, train further models. And there are some settings maybe you can use with the API to kind of turn that off in some cases. But a lot of times, if you want to be using a lot more secure of an environment, you want to be using these local models where they're not directly tied to an API where you're doing these requests to an external server. That's if you're doing something where it's more really sensitive information, you're going to want using more of a local model or more of a open source model where you've kind of fine-tuned for your specific purpose and not actually using an API call to another company where it could be leaked in some case.
Awesome. Akmal, anything you want to add to that before I
No,
jump
I
to the
think
next
that's
one?
Ayush has covered it really well there, Matt. And the only thing I would add is that I think I understand correctly that OpenAI, by default, they don't retain your data. You specifically have to give them permission to say yes, you're allowed to keep it, or if you want to train your LLM on it, you're welcome to have our data. But other than that, the default is they don't retain it, which is probably a good policy to have.
Good stuff. I've also seen a couple questions around, what if can I use Excel sheets? Can I use images? What about PDFs? And this is also kind of reminding me of, I feel like we've gotten questions in past webinars where people say hey, I've had some problems with PDFs. Unless I really organize the PDF in the same way every time, it's having trouble figuring out what that content is in the PDF based on the layouts. So I wonder, and maybe this is something OpenAI is trying to get better at, but I wonder if you guys have any thoughts on that, either Ayush or Akmal.
Yeah, so there's definitely some issues maybe with PDF analysis where, based on like the organization of the PDF, it might be giving you different outputs. I'm not too sure on a lot of the specifics. Akmal, do you have any more thoughts to that?
Yeah, I was thinking quickly on this, Matt. I know we're almost at the top of the hour. So for the PDF, I mean, typically use something like LangChain, for example, which has got a whole bunch of technologies that can handle PDF documents. And then, of course, that's great for text, but what about things like images, and charts and tables that occur in PDF documents? I think the technology is much better to the point now where we can handle these reasonably well. And certainly, it's a lot better than using OCR. A quick example, we actually had a customer come to us that was dealing very much with a kind of insurance sort of claims in documents where they had to use OCR. Switching to LangChain, they reduced the errors considerably. I mean, basically, it
Okay.
was automating that process for them, and it was doing a much better job. They are a lot happier today. It's not perfect, but it's a much better solution than what they had previously.
Hmm.
Awesome. Very good. Okay, quick note before we announce the AirPods winner. Just a reminder, as I mentioned during the intro, on Wednesday, we will be presenting how to create embeddings on real-time data using OpenAI and SingleStore's new job service. Once again, that's the demo where we will be showing how to use SingleStore's new feature. It's a job scheduler to be able to create scheduled embeddings on data. I think they're going to do a demo maybe on new data coming from Reddit and or Twitter, maybe some other sources. So if you want to see that demo, go ahead and RSVP right now. I just put the link in the chat, and I hope to see you on Wednesday. And then the announcement you've been waiting for, today's AirPods go to Gima Zhu, who is a scientist at Gilead Sciences. Very cool. It's interesting for me to wonder what Gilead Sciences is going to be using this cool new technology for. Thank you for joining. If that's not you, don't give up. We're going to give out one more AirPods later today to a raffle for anyone who tries out this service, either free trial or free tier, as we mentioned. So keep an eye on your email. We will be sending out the GitHub for this. We'll also be sending out the recording for this session. Thank you so much to Ayush and to Akmal for another awesome session. And thank you to our audience as well for sticking it out with us. Thanks, and hope we'll see you again soon. Bye, everyone.
Thank you, everyone.